All right, so at this point we've seen how to solve a quadratic using the factoring method and the graphing method. Today we're going to move on to something called the quadratic formula. So today you're going to be solving those quadratics using the quadratic formula, which some of you may be familiar with already. But before we do that, there's a couple of things that we've got to talk about first. Up here at the top it says all the quadratic equations solved up to this point have had two real solutions or roots. In some cases they involve a double root, but there was always two solutions, and that should be the case. Remember, we have that theorem, fundamental theorem of algebra, that said that if we have a degree of 2, we should have two complex roots. So here we have the quadratic 0 equals x squared plus x plus 2. First thing they ask us is, can this equation be factored in order to find its solutions? In other words, that test you just took, can I take x squared plus x plus 2 and factor it out? Well, let's try here. I know x times x will give me the x squared. Are there two numbers I can multiply together that would give me 2, but would also add up to the middle term 1? What two numbers can I multiply together to get 2, but are also going to add up to a 1? 2 and what? Can we? Are there two numbers that we can multiply together to get 2, but would also add up to a 1? Now, there's not a whole lot of things that we can multiply together to get 2, is there? The only thing we can multiply together to get 2 is a 1 and a 2, or a negative 1 and a negative 2. And neither one of those is going to add up to a positive 1. So there are no factors for this right here. No factors. How about the next one here? Can we find the solutions, or the zeros, by graphing? Well, let's find out here. Let's go to our calculator and let's graph x squared plus x plus 2. Let's see if we have some x-intercepts. Nope, no x-intercepts. And yesterday what we said is if there was no x-intercepts, then we had no real solutions. We have solutions, they're just not real solutions. And that's what we're going to take a look at today. What do we do if we have no real solutions? We can't do factoring and we can't do graphing. So we got to come up with another method to come up with those solutions. So here it says we do still have two solutions to that quadratic equation. It just so happens they're not real numbers though. Instead, what we're going to end up with is imaginary. Now there's a couple of ways that we can define an imaginary number. First, over here it says that I is the number you can square to get an answer of negative 1. So for example, I squared would equal a negative 1. And that's one way we can define it. Or we can also say that I is the square root of a negative 1. So I would be the equivalent of the square roots of a negative 1. So we can define it either one of these ways. So I is going to represent the square root of a negative 1. Here it says the square root of negative numbers can be simplified using an I. If x is a non-negative real number, then the square root of a negative x would be equal to a square root of a negative 1 times x, which is equal to the square root of a negative 1 times the square root of x, which is equal to an I square root of x. Y'all get that? You ready for the quiz now? No, that didn't make a whole lot of sense. It'll make more sense once we look at some examples. So let's take a look at some examples so we can understand what the heck that's saying. So if you look at our first example over here, the square root of a negative 49. Try and put that in your calculator for us. Let's see what happens. The square root of a negative 49. What is the calculator going to give us if I put the square root of a negative 49? Non-real answer. So it's not going to give you an answer because there is no real answer. So up here what this is saying is the square root of negative 49 can be simplified as the square root of negative 1 times the square root of 49. And the reason we're breaking it apart like that is because the square root of negative 1, we just defined that as an I, didn't we? So that square root of negative 1 now becomes I. Notice we can also take the square root of 49 now, since it is a positive. And what's the square root of a 49? 7. So what we have here is the square root of negative 49 is 7i. 7i would be our answer. Let's try that again. B, the square root of a negative 121. Again, up there at the top, all it says is we can break this apart, simplify it, and rewrite it as the square root of negative 1 times the square root of 121. Again, the reason I'm doing this is because I can take the square root of negative 1. We define the square root of negative 1 as an I. And, of course, the square root of 121 would be 11. Now, as you get more and more comfortable with this, are we really going to need to break it apart like that? No. Let me give you a couple more examples. What if I ask you what's the square root of a negative 25? What's the square root of a negative 25? 5i. What if I ask you what's the square root of a negative 36? 6i. What if I ask you what's the square root of a negative 100? 10i. Are we needing to break this apart to get that answer? No. Okay, so as you get comfortable, you can do that as well. All right, let's do the next one, C here. The square root of 17 minus 42. Well, first of all, what is 17 minus 42? Negative 25. So the next question is, what is the square root of a negative 25? We just did it. 5i. So 5i is the square root of 17 minus 42. E, 12 plus the square root of a negative 36 divided by 2. First thing I want to do is take the square root of the negative 36. What is the square root of a negative 36? 6i. So now this becomes 12 plus 6i divided by 2. I'm not going to leave it like that, though, because we are dividing by 2. So we're going to take both parts, the 12 and the 6i, and divide both of those by 2. So 12 divided by 2 would be a 6, and a 6i divided by 2 would be a 3i. So we end up with 6 plus 3i. Got one more over here we're going to look at, and that's D. That's right here. The square root of a negative 3. Square root of a negative 3. Well, here's what I know. I can break it apart or simplify it as the square root of negative 1 times the square root of 3. I also know that the square root of negative 1 is I. But what's going to happen if I try and take the square root of 3? The long decimal. And I don't want that long decimal. What I'm going to prefer is the square root of 3. Don't give me decimals. Leave it in this radical form. So we're going to write it as I square root of 3. Now we're only going to need to do that if it's not a perfect square. In other words, if we get a decimal, we'll leave it like that instead. Now later on, we may be able to simplify, but at this point, we're going to leave them like that. That's a whole other lesson.
Does it matter if you put the I in front of that?
You'll see in a minute, yes, it is going to make a difference. As a matter of fact, we're going to talk about that right now. Oh, let me make sure. You're talking about this right here?
Yeah.
This I? Yeah, it's not going to make a big difference. You could put square root of 3. Just make sure that the I is on the outside of a radical. Yeah. Just make sure it's not underneath the square root. It's got to be on the outside. It wouldn't make a difference. All right, now we're going to look at something called a complex number. Complex number. And it says here that a complex number is the sum of a real number and an imaginary number, usually written in the form A plus BI. A being the real part, the BI being the imaginary part. Of course, we can tell the imaginary part because it's the one that has the I. So on these examples that they've given us, they want us to write each of these in the A plus BI form, or the complex number, and then for us to identify what's the real part and what's the imaginary part. It says here, simplify first if it's necessary. All right, so here we go. F, 25. They want me to write that as a complex number. So here's how it's going to look like as a complex number. It's going to be 25, it's the real part, plus 0i. Since there is no imaginary part, I'm going to add it in there, but I must put a 0 in front. Now that I have that complex number, they want me to identify what's the real part and what's the imaginary part. So the real part of that complex number would be the 25. The imaginary part of that complex number would be the 0i. So the real part is going to come first, then the imaginary part. G, 25i. We want to write that as a complex number. So the complex number would be 0 plus 25i. There was no real part, so I put a 0 in front of it. So now that I have that complex number, let's identify both parts. The real part's going to be the 0. The imaginary part's going to be the 25i. H, we have 3 minus 5i, which is already the complex number. It's already in that a plus bi form, so we don't have to change anything there. But we do need to identify what's real and what's imaginary. All right, so Annika, what's going to be the real part? 3, and the imaginary part would be the negative 5i. So 3 is the real part, negative 5i is the imaginary part. Okay, let's go on over to I. Get this out of the way here. First, we got to simplify here, so let me see. 9 plus the square root of a negative 144. Well, what's the square root of a negative 144? What was that? 12i. Don't forget, we do have to divide by 6. Make sure you divide both of these by 6, both the real part and the imaginary part. So 9 divided by 6 would be what? 1.5. 12i divided by 6 would be a 2i. So that right there is our complex number. That's our a plus b. Now let's go ahead and identify what's real and what's imaginary. Our real part's going to be the 1.5. The 2i would be the imaginary part. J, we got 3 plus 5i minus 7 plus 8i. Got to simplify it first. We're going to combine all the real parts, then all the imaginary parts. So if I put all the real parts together, the 3 minus the 7. 3 minus 7 would be a negative 4. Then put your imaginary parts together. 5i plus 8i would give you 13i. That right there is our complex number. That's in the form a plus bi. Now go ahead and identify the real and the imaginary. So what's the real part? Negative 4, and the imaginary part is the 13i. Last one over there is a little tricky. We need to multiply the 6 plus 2i times the 6 minus 2i. So we're going to have to do some FOIL. There's a little more work involved in this one. So here we go with FOIL. 6 times 6 is 36. 6 times negative 2i would be a negative 12i. 2i times 6. 2i times 6 would be a 12i. And 2i times a negative 2i is a what? Negative 4i squared. We're not done. We're going to clean that up some. What do you notice about the two terms in the middle? They cancel out. All right, so negative 12i plus 12i is 0i. So there is no more I over there. What else do you notice? The I squared. And at the very front here, at the very beginning of our notes, we define I squared as a negative 1. So that right there now becomes a negative 1. Which means a negative 4 times a negative 1 makes this a positive 4. And 36 plus 4 is a, what? 40. So we end up with a final answer of 40. But remember, we are going to write it as a complex number. So what's the complex number going to be? 40 plus 0i. So let's do the real and the imaginary. The real part is the 40. 0i is the imaginary part. All right, so that's a little quick lesson on how to work with the complex numbers. Let's keep moving here. The next thing we have is something called a conjugate. And it says here the conjugate of a complex number is when we have the same real part but the opposite imaginary part. So for example, 2 plus 3i. The conjugate of 2 plus 3i would be 2 minus 3i. The only thing that's changing is the sign on the imaginary part. The real part stays the same, regardless of what number you're working with. Notice right here, it also says when complex conjugates are added or multiplied, the result will be the imaginary part being 0i. That's always the case. So, over here they give us some examples. They tell us to find the conjugate of each of our complex numbers. Now remember, to find the conjugate, all we're doing is changing the imaginary part to its opposite. The real part's going to stay the same. So, 25. What's the conjugate of 25? Well, is there imaginary part on this one then? No. So there's nothing we need to change. It's just going to stay 25. Nothing to change. We're only changing the imaginary part. What about m? 25i. What's the conjugate of 25i? Remember guys, right here it says the real part stays the same, but the imaginary part's going to be opposite. So that's the imaginary part. What's the opposite of 25i? Negative 25i. N, negative 3 plus 6i. I'm looking for the conjugate. All we're changing is the sign on the imaginary part. So now this is going to be a negative 3 minus 6i. It's only the middle number that's changed, or the sign there that's changing. Negative 12 minus 5i, the conjugate of that would be negative 12 plus 5i. Notice how that real part stays the same. It's only the imaginary part that we're changing. P, what's the conjugate of 2/3 minus 1/5 i? 2/3 plus 1/5 i. And finally the last one there, Q, 5 plus I square root of 3. The conjugate of that would be 5 minus I square root of 3. And there we have it. So again, conjugates just means we're changing the imaginary part to its opposite. The real part is going to stay the same. Don't do anything with the real part. Moving on, solving equations with complex numbers. Some quadratic equations can be solved by isolating the variable and taking the square root of both sides. So we're going to work on r over here. We got 6x squared plus 96 equals 0. What we're going to do is we're going to solve for x. So what we're going to do first is we're going to start by subtracting the 96. So that's going to leave me with 6x squared equals, what's 0 minus 96? Negative 96. I'm still solving for x, so the next thing I'm going to do is come over here and divide by 6. So help me out with that. What is a negative 96 divided by 6? Negative 16. Negative 16. I'm still trying to solve for x here. So I got to undo the square. And the opposite of squaring something would be to take the square root. So what I'm going to do is I'm going to take the square root of both sides. Remember, whatever you do to one side of the equation, you got to do to the other. So I'm taking the square root of a negative 16. What's the square root of a negative 16? 4 what? 4i. We got a problem here, though. How many solutions are we supposed to have when it comes to quadratics? 2. How many do I have up there? 1. Why? What's going on here? Well, remember, we're taking the square root here. We're going to have a positive square root of a negative 16, which is the one we have found right here. But we're also going to have a negative square root of negative 16, which would end up giving me a negative 4i. So there's that other solution. So 4i and negative 4i would be the solutions to this quadratic. Notice how both of those happen to be imaginary solutions. All right, so these are my solutions. Andy, what do you notice about those two solutions? They're conjugates. Notice how they're conjugates of each other. 4i and negative 4i are conjugates. We have opposite imaginary parts. Keep that in mind. Keep that in mind. Let's keep going here. Over here, they ask us to describe the complex numbers below by filling in the table. So, for number 1, the first thing we need to do is simplify the square root of a negative 21. So, Marisha, what's the square root of a negative 21? 11i. That's the first part. Now they want us to identify the real part of that complex number. Well, do we have a real part? No. So what are we going to write here? 0. No real part. How about the imaginary part? The imaginary part for us is going to be the 11i. And Lindsay, what are we going to have for our complex conjugate? What's the conjugate of 11i? Negative 11i. That is correct. There's your first. Number 2, negative 56. Simplify. Well, you can't. It's already done. There's nothing to do with negative 56. Real part. Well, that is the real part. Negative 56. Imaginary part. What am I going to write for imaginary part? What's my conjugate going to be for a negative 56? Negative 56. Remember, we don't change that one. We only change the imaginary part. The real part stays the same. Okay, going on to the next one. 85 plus the square root of a negative 169. Well, what is the square root of a negative 169? Square root of a negative 13i. 13i. So we have here the complex number 85 plus 13i. So what's our real part going to be? The 85. The imaginary part's going to be the 13i. And 85 plus 13i, the conjugate of that would be 85 minus 13i. So again, we're only changing the sign on the imaginary part. The real part stays the same. All right, next one we have is negative square root of a negative 16 over 49. Let's ignore that first negative sign there. Right now, all I need to know is what is the square root of a negative 16 over 49? What's the square root of a negative 16 over 49? What's that? Try that again. Again, we're ignoring that first negative sign. Let me ask it another way, guys. I know what the negative sign inside the square root is going to do. It's going to give me an I. I know that much. So the next question is, what's the square root of 16 over 49? You can put that in your calculator. 4 over 7. I want you to notice what happened there. All we did was take the square root of 16, which was 4. We also took the square root of 49, which was 7. So all we did was take the square root of the numerator and the denominator. However, that's not the final answer just yet, because there was a negative sign in front of the square root, or the radical. So we need to make sure we keep that negative sign here. That negative sign right there is the one that's in front of the square root. All right, there is the simplified form. What's the real part? 0. What's the imaginary part? Negative 4 7 i. And the complex conjugate of that would be 4 7 i. Number 5, square root of a negative 5. Square root of a negative 5. Well, I know the square root of a negative is going to give me the I. But what's going to happen if I try and take square root of 5? You get a decimal. And we don't want that decimal, so we're going to leave it as the square root of 5. Okay, so we just simplified it. We end up with I square root of 5. Real part. Real part here is going to be a 0. The imaginary part would be the, what? I square root of 5. And the conjugate of that would be negative I square root of 5. We're always taking the opposite of the imaginary part. Number 6, we got to do some simplifying here. I'm going to take the real parts and put them together. So 3 minus 9. 3 minus 9 would give me a negative 6. Put your imaginary parts together. A negative 14i plus 5i would give us a negative 9i. So there it is. We've simplified. Real part would be the negative 6. The imaginary part is going to be the negative 9i. And the conjugate of that negative 6 minus 9i is going to be negative 6 plus 9i. We got one more here, and it is 5 plus 2i squared. Now this one right here, we're going to have to do some work. They didn't quite leave us enough room here, so we'll try and get it squeezed in here. Okay, we're going to have to do a little FOIL on this one, guys. So here we go with the FOIL. 5 times 5. 5 times 5 is 25. 5 times 2i, 10i. 2i times 5 is 10i. 2i times 2i is 4i squared. What's going to happen with the two terms in the middle? Are you sure? You can add them together. And what do you get when you add them together? 20i. So right here we have 25 plus 20i. You'll notice that we also have an I squared. And that I squared is a what? It's a negative 1. Which means that 4 times a negative 1 is a negative 4. Which means we can do one last thing here, and that's to combine the like terms. 25 minus 4. 25 minus 4 is a 21. So we finally end up with our complex number, and that complex number is going to be 20 plus 20i. All right, so what's the real part? The real part is the 21. The imaginary part is the 20i, and the conjugate would be 21 minus 20i. Got to change the sign on that imaginary part. We're good? You still with me? Kiki, you're good? You ready for the test? Not yet, right? Let's keep going. Solve the following quadratic equations and describe the quadratic solution. So it's kind of like the ones that we were doing a second ago. We're going to solve for x. So as I was doing earlier, I'm going to start by subtracting 50. So 0 minus 50 is negative 50. Divide by 2. Negative 50 divided by 2 is negative 25. The opposite of squaring something would be to take the square root of it. So the square root of a negative 25 would be a what? What's the square root of it? Negative 25. 5i. 5i. How many solutions are we supposed to have? 2. Right now we have the positive square root of negative 25, but we also need the negative. So we're also going to have a negative 5i. Once again, what do you notice about those two solutions there? I heard it. Say it. Huh? They're conjugates. Notice how they're conjugates of each other. Number 9. Just like we did 8, we're going to get x by itself. So let's see, I'm going to add 8. So 100 plus 8 is 108. Next thing I need to do is divide by -3. So 108 divided by -3 is what? -36. We're almost there. Opposite of squaring something is to take the square roots. And the square root of a -36 is 6i. But again, don't forget we do have two solutions. We got the positive square root of -36 and the negative square root of 36, which would mean I would also have -6i. So once again, notice how they are complex conjugates. All right, guys, we're running short on time here, so I'm going to skip number 10. We'll come back to it if we have time. Let's move on. I want to make sure I get as much done as possible here. Next one says here, any quadratic equation, including those that have imaginary or complex solutions, can be solved using the quadratic formula. Now, every single person in here has seen quadratic formula, correct? You saw it back in Algebra 1. Probably even saw it in geometry as well. When you're working with quadratic formula, over here we're given a couple of steps. Before you can use quadratic formula, you do have to make sure the equation is equal to 0. Once you've got it equal to 0, you're going to identify what is A, what is B, and what is C. Once you do that, you can take those values and plug them into the formula, and then simplify to come up with your two solutions. So those are the steps that we're going to follow when working with quadratic formula. But before we start working with that formula, we're going to look at something called the discriminant. Discriminant. The discriminant is b squared minus 4ac. I want you to look at the quadratic formula, guys. Everybody look at your formula. B squared minus 4ac. Where can you find that in the formula? It's inside the square root. So notice what that is the part that's underneath the square root. That's what the discriminant is. Now, depending on what kind of number we get for our discriminant, will tell us what type of solutions we're going to end up with. Now, I'm not going to go through all the samples, but I do want you to be aware of what kind of solutions we can end up with. The first one here says if the discriminant, or if the number underneath the square root is equal to a 0, what's going to happen is we're going to end up with one rational double root. We're going to have one of those double roots. But that's only going to happen if the discriminant, or the number underneath the square root, is a 0. The next thing we have here is if the discriminant is greater than 0, in other words, if it's a positive number, and is also a perfect square, and they give you some examples of perfect squares, like a 1, a 4, a 9, a 16, 25, 36, 81, and so on and so on. If we get one of those numbers underneath the square roots, then we're going to have two rational roots. If our discriminant is greater than 0, or a positive number, but is not a perfect square, then instead of two rational roots, we're going to get two irrational roots. And the last thing we have is if our discriminant, or if our number underneath the square root is a negative number, we're going to end up with two complex roots. In other words, we're going to end up with those conjugates involving the imaginary numbers. Those are the ones that we were just looking at a second ago. So this right here only tells us what type of solutions we're going to get. It doesn't tell us what the answers are. It doesn't give us the solutions. It just tells us what type of solutions we have. All right, so let's get going here. Let's see how many sample problems we can get through. For number 1, they ask a couple of things. Part A, they want us to write the equation in the form ax squared plus bx plus c equals 0. So we got to get the equation equal to 0 first. So let's go ahead and do that first step. Step A. 3x squared plus 7x plus 2. So notice I moved the 2 to the other side by adding. That right there is the first step, or the first thing they ask. Second thing they're asking for is for us to find the discriminants and use it to describe the nature of the roots. All right, so the discriminants was this little formula right here. B squared minus 4AC. That right there is our discriminant. What we're going to do is take out the letters and replace them with some numbers. What number am I going to use for the B? 7. What am I going to use for A? 3. And for C, we're going to use the 2. All right, we don't need to make this complicated. Just stick that in your calculator and let's see what number we end up with. 7 squared minus 4 times 3 times 2. See what you get. We get a 25. Now what we need to do is describe the nature of the roots. So we got a positive number. So go back to that little chart that I gave you. Go back here. This is what we're looking at. We got a positive number, which are the green and the blue here. We ended up with a 25, which is a perfect square. So it says we're going to have what kind of solutions? 2 rational roots. All right, so over here, we're just going to write down that we're going to have 2 rational roots. 2 rational roots. The third step is to find those 2 rational roots. And we're going to find those rational roots using our quadratic formula. So now we're going to go through the whole formula itself. So this is part C here. So the formula was x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. That's the formula. Is that a formula you have to memorize? No, it'd be good if you memorize it, but it is on our formula chart that we get to use. So, no, you don't necessarily have to memorize. All right, so let's start plugging in some numbers. Remember earlier we said B was going to be our 7. 7 is B. A we said was 3. C was a 2. And A again was a 3. So this right here is the numbers plugged into the formula. Remember, A, you can find that in front of your x squared. B, you can find that in front of your x. And C, that is going to be your constant. So let's start doing the work here. Negative 7 plus and minus. Now, guys, you've actually already done this part underneath the square root. That was our discriminant. And what number did we come up with? 25. So you don't need to do it again. We've already done it. 2 times 3. 2 times 3 is a 6. Notice that we can take the square root of 25. The square root of 25 is 5. So here's what I'm looking at so far. Now remember, we're going to have 2 rational roots. So how do we get the 2 rational roots? We're going to take this and we're going to split it apart. Notice there's a plus and a minus between the 7 and the 5. So to find one of the answers, we're going to do negative 7 plus 5 divided by 6. To get the other one, we're going to do negative 7 minus 5 divided by 6. So for the first one, what is a negative 7 plus 5? Negative 7 plus 5 is negative 2. And a negative 2 divided by 6 can be reduced to what? Negative 1/3. There's one of your rational roots. Let's go and find the other one. Negative 7 minus 5. Negative 7 minus 5 is a negative 12, and a negative 12 divided by 2 is a, divided by 6 is a negative 8. The answer. All right, so the 2 rational roots end up being negative 1/3 and a negative 2. All right, guys, we're going to go ahead and stop right there. We'll pick up there on Monday.